Hello class, this is the lesson on Chapter 7, Lesson 4, and today we're going to be talking about solving two-step equations. On page 534 is where we're going to begin, and we have a really brief review. First of all, one of the big ideas you're going to have to remember is the idea of the order of operations, otherwise known to most students as PEMDAS. And this is just the list of rules we follow when we're solving equations with more than one operation. So basically we have more than one thing happening, such as 2 times 5 plus 3. It tells us the order that we're going to go in to solve this. For example, we have no parentheses or exponents, which is what the P and the E stands for. Now it says to do either multiplying or dividing, whichever we see first. And in this case, we have some multiplying. So 2 times 5 is 10. And then we add or subtract, depending on which we see first from left to right. And we have 10 plus 3, which is 13. So it's basically just a set of rules on how to get an answer when you have more than one thing happening in an equation. But now, since we're doing basically algebra, we're going to be working with it in a different way. Now today we're going to be focusing on what are called two-step equations. Two-step equations just means it's a math problem where you have two things happening. In this case, we have 2x plus 3 equals 9 in this example here. We know 2 and x being next together means we have multiplication, and then we also have addition. So the two steps in this equation are multiplication and addition. Of course, you can have any mixture of add, subtract, multiply, or divide, but we're only going to be working with any two of these at a time. There are two main rules for working with two-step equations and solving them. The first one is undo the addition or subtraction first. The second rule is undo the multiplication or division second. This will become more obvious when we start doing some of these examples, so let's go ahead and just jump right into it, shall we? So I'll go ahead and let's go up to example 1. And in your notes, I would suggest you do a lot of this work on a separate sheet of paper because there's really almost no way to fit this in the margin of your book. So I'm going to go ahead and pull up a blank section that I can work with to do my work. And I would suggest that how I set up my work here would be the way you should do your notes. So let's go ahead and begin. First of all, just like we did with one-step equations, we want to begin with writing our equation all over again. So 2x plus 3 equals 9. Now I'm going to go ahead and make 3 sections to solve this, and you're going to find out why as I progress through the problem. So our first step, like always, like we did one step, was to identify our variable. Our variable is the letter x. Now since we're dealing with two-step equations, I'm going to go ahead and make a little chart here, a t-chart. And this t-chart is going to help guide me in my problem solving. First, I want to talk about what we see happening to the variable x over here. Here I have x next to the number 2, and then I have a plus 3. That tells me I have multiplication times 2 and addition of 3. So I'm going to go ahead and make a little note of that. I know I'm multiplying x times 2, and then on this side I'm going to write, then I'm adding plus 3. All I did was talk about what's happening in this equation. Now, if you notice I have two spaces underneath. These two spaces tell me how I'm going to solve this equation. And the way you do it is you look at the top part, you say, okay, I have multiplying times 2. What is the opposite or inverse of multiplying times 2? Well, that would be to divide by the number 2. What is the opposite or inverse of adding 3? That would be to subtract 3. These two steps are going to be what I'm going to do to solve for x in this equation. And let me explain to you now how it's going to work. I told you in the beginning of this section that we're going to be using the order of operations, or PEMDAS. Now we're going to be using the rules we learned above, and at first it said to always clear up any addition or subtraction you see first. So here I have subtraction of 3. I'm going to subtract 3 from the place where I got it over here, which is from the plus 3. My equal sign acts like a wall and just drops down. And I'm also going to subtract 3 on the right-hand side, because remember, when I have an equation, whatever I do to the left-hand side, I have to do to the right-hand side in order to keep this whole thing balanced. I didn't touch the 2x over here, so it's just going to fall right on down. And I'm going to proceed to work from left to right. I was adding 3, then I subtracted 3 over here, and that just cancels out to 0, so nothing happens over here. My equal sign, go ahead and jumps down, and I have some math. 9 minus 3. That's pretty easy. 9 minus 3 is 6. So now I've gone ahead and done this first step. The second step in my notes above said to get rid of or undo any multiplication or division. I'll do that, according to this, by dividing by 2. I'll divide the left-hand side of my equation by 2, and the right-hand side of my equation by 2. Here I have 2x divided by 2. 2 goes into 2x one time, so I'm left with just a 1x. Over here, I have 6 divided by 2. 6 divided by 2 is 3. Recall that all fraction problems are basically just division problems. If you didn't remember that, I would suggest making some notes over here on the side. You will be graded on your notes, so it's very important that you have some work present to show and turn in. So now we have a solution. We think that 1x, or we can just call it x even, I don't even have to have the 1 there, x equals 3. But like all math work, you can check it, and with algebra and these equations, you really need to check it. But that is very, very easy, and that's what this third column is for over here. We're going to go ahead and check our work. You begin by writing your original equation, 2x plus 3 equals 9. We think that x should be equal to 3. So that means when I do my check, wherever I see an x, I'm going to plug in a 3. So 2, plug in a 3 with parentheses, plus 3 equals 9. Now I'm going to go ahead and just follow the order of operations over here on the left-hand side. I have multiplication and addition. I know multiplication comes first. 2 times 3 is 6, plus 3 equals 9. Now I have one step, 6 plus 3. Well, 6 plus 3 is 9. 9 on the left equals the 9 on the right. This is a true statement, which means that this is a right answer. And this is a multi-step procedure, but it is going to be what you're going to repeat over and over and over again in algebra to make sure you always get the right answer. And we're going to practice this some more. Don't be afraid if you didn't understand it all the very first time. With practice, it'll start coming to you. If you looked over here on the left-hand side of our notes, we have something very interesting. It says stop and reflect. What are the 2 operations you would perform to solve 3x minus 4 equals 8? Write your answer below. Well, in our equation up here, the operations we had was multiplying times 2 and adding 3. What we did to solve was division of 2 and subtraction of 3. So I'm going to try to use that same logic over here. I'm going to make a little t-chart. My little variable here is x also. I have multiplying times 3 right next to it, and I have subtracting 4. Well, what are the opposites or inverses of multiplying? That would be dividing, and the inverse of subtracting 4 would be to add 4. So to answer the question, what are the 2 operations you would perform to solve this? I would perform division and addition. It's really just all about opposites. I should see these answers and this response in your notes when I do grade them. Now, if you have any questions still about this example, please write them somewhere on the side and have them ready for class when we present and to discuss this. I'm going to, in the meantime, go ahead and move on to the next page.